This is part 11 in a series of videos in which I'm attempting to repair this Wren executive computer. In the previous videos I got as far as replacing some faulty memory chips, tracking down some various faults on the peripheral data bus, a few other minor issues with some glue logic. But if you recall from an earlier video, I attempted to do some fault finding with the Fluke 9010A, and the results were a bit ambiguous, and although it found some ROM, it didn't find any RAM, and the in-out it found were a little bit ambiguous as well. So after correcting the faults as far as I can, I'm now waiting for a replacement floppy drive controller chip. I thought I'd do some more fault finding, and specifically what I wanted to do, and what I tend to do with machines I'm repairing, is do a bit of stress testing to see if there are any other potentially weak devices that need weeding out. And the way I go about doing that normally is to attach the Fluke. That's the main function I use it for, and I can essentially run the machine using the Fluke. I can send specific commands and I can loop it round continuous tests. If you saw the series on the HP calculator repair, in that machine I had to write specific firmware routines and write them into a ROM, because it didn't have a processor in the standard sense. It was a discrete machine, but because this uses a specific processor, I can pull the processor out, plug the Fluke in, and then I can run specific tests, and that allows me to do all manner of different tests on the various parts of the machine. So the first thing I wanted to do was to address this issue with the RAM not being detected. I did say that potentially it was because the RAM was in a different bank, but that seemed extremely unlikely. And one thing I've seen many times, which is what I suspected it was, and using the scope and a little probing around proved to be the case, is that it was caused by the buffer chip between the CPU socket and the RAM bus. I've replaced that device, and I'm now going to retest it. I thought it might be an interesting video just so you can see the difference. Although the machine was running and it didn't really show any apparent issues, one of the things the Fluke is quite useful for, once you kind of realise it's going to do it, is that the Fluke being attached means that you need far more drive coming out of the board, in other words coming from the buffer chip back to the Z80 socket, and if you don't have enough drive, then you'll get some fairly odd behaviour, and it's a good way of checking if the various buffer chips are up to scratch, along with all the glue logic chips as well that are involved in that process. And then once that's working, you can actually start looking at running specific tests to look for other faulty devices on the machine. If you don't do that, you can end up with a machine that might work intermittently. It might work for a week and then stop working, or you might have weird and wonderful failures or apparent instability. And doing this and carrying out this process means that for the most part you can weed out a great many potentially weak ICs. Okay, so what I'm going to do, I've got the Fluke plugged in already, as you can see. One thing I'd point out here is this pod is for the Z80AA, and so I have a C version of the Z80 in here that in theory should work to 10 megahertz. What I found is that because of the cable it will only work to about 8, but as the Wren clocks the Z80 at 6 megahertz, then this is fine. It shouldn't work. It should work without any problems. So I'll move the camera so we can see the Fluke, and we'll rerun the learning test that I did in a previous video and see what the results are this time. Okay, so obviously we're looking back at the Fluke. I'll power up the Wren, and just to make sure the Wren is fully reset and doing what it's supposed to, I will just run it. Ignore this step. This is just to make sure that it's gone through its self-test and set any registers or any banking buffers or latches that it needs to. So okay, it's gone through its self-test. Although it says may need reset here, it actually doesn't require a manual reset. So the Wren is now running, the display's come up and it's finished its self-test. We've got a solid light on the keyboard. So what I'll do now, and apologies if the display is flickering, unfortunately that's just an artifact of the way this display works relative to the shutter speed of the camera. So what I'll do, I'll run it through the learn process again. So same address range as we used last time, that's from 0 up to FFFF. That's the directly addressable memory space of the Z80. As previously, it will take quite a long time to complete, so rather than making you sit through that again, I'll just get it started and then I'll jump us to the end of the test. Take about 15 to 20 minutes and I'll come back on camera once it's completed. Okay, so I travelled forward in time 20 minutes there. I'm 20 minutes older and you're all still the same age. As you can see, the test is finished, and what we'll do now is we'll look to see if it's actually found anything this time. So ROM, we know that previously it found something in this address space, and it still seems to have found the same thing. It's still given the same signature 1A02, which I have to assume is correct. I can't find any information about what the signature should be for that block, and that's all it's found. If you recall, previously it actually found several blocks of ROM which seemed a bit strange, but this time it's only found the one which is correct, and that's also in the correct memory address space. There is a second ROM chip, but it's in a different bank, and that's one of the things I'll be able to do later with the Fluke, is to switch to a different bank manually and then repeat this test to see if that ROM can be read successfully as well. In-out space, there's no info on in-out space, and that's what we would expect because the in-out should be mapped out. It shouldn't be in this space. And then RAM, which we weren't getting any RAM before at all, and now we can see we are getting some RAM. And if we look at the manual, and if we look at this is actually the error code list, it tells you what the addresses for various parts of the address space are, and it's saying that the video character RAM is from 4000 to C triple F, and as you can see we're getting RAM at 4000 to C triple F, so it's found the video RAM. I actually already knew it had found the video RAM. If you've used one of these and you've tested video RAM, you'll know that the Fluke writes values to the video RAM as part of the test, and you can see that on the screen because obviously it changes the contents of the video RAM, and the contents of the video RAM determine what's on the screen, so you can see that occurring during the test. You can see the values moving down the screen as the test is carried out. So there are more RAM locations that it found, and the next one is at F000 to FFFF, and again if we look we can see that that is correct. That's the common RAM, that's the DRAM, and that's been found as well. So that's what we found. Now it's saying here that there is some more video here that's for graphics mode, but that's within this block, so it's actually found all this and it's all lumped together, but it tests it separately. But they are the 4 video RAM chips. So it's actually found all these and that's worked fine, and that's it. We're not getting any other small blocks of RAM or ROM or in-out space, so that's all working fine. So as I said, what I can do now is run various tests with the Fluke. I can send commands to the system, I can switch banks. As you know, I've created an in-out table so I know what addresses I'm looking for. This is where the Fluke starts to come in handy. As I mentioned in a previous video, it's not very useful for doing initial fault finding on a completely dead system as we had, simply because it's not smart enough, it gets confused. But once we've got the system up and running to a certain point, then it does start becoming increasingly useful to iron out any kinks or look for some particularly hard to find faults. It can be extremely useful for doing that. that's it for this video. If you want to see any more testing carried out with the Fluke, then let me know. It is a very powerful device once you have a target machine that's fundamentally running, and it does allow you to find faults with specific RAM chips. So if you got say one of the 8 RAM chips that wasn't working, then it becomes very evident as to which particular chip that is when you carry out various tests. There are of course specific tests for the RAM, the control bus, in-out. You've got short RAM tests, long RAM tests, and that allows you to do very in-depth testing for the devices on the system. It's also quite useful for testing the video display. If you want to test the various modes, then you can do that by writing specific values to the video RAM. You can do the same thing with the common RAM, but it's not quite as useful there because you can't really do much other than read it and write it. Okay, so as I say, if you want to see any more testing with this, then let me know.